Hi, good afternoon, everyone. So today we have Prof. Tsukasa ISHIZAWA from Japan, Takenaka Corporation and University of Tokyo to share with us his computational BIM experience and interesting topics. So Prof, are you there?
Hi, good afternoon.
Hi. So yeah, you want to share your screen. You can actually start with your presentation. My apologies for today, as Aloysius' side got some issue, so he cannot attend, and he sent his apologies to everyone. So yeah, so Prof, yeah, please take over from here. Thank you very much.
Okay, then I will share my screen and start my presentation. Looks good? Okay, so thank you very much for having me for this session. I'm Tsukasa ISHIZAWA from Takenaka Corporation. At the moment, I'm a research professor in University of Tokyo as well. So today I'd like to introduce some recent project from Takenaka side and some research insight from the university side. And also I'd like to talk a little bit about the future or the next step for this BIM and computational design field. So as I mentioned, I'm in Takenaka for already 70 years. And basically I'm an architect and I was a project architect for more than 10 years. And I was involved in the commercial and the industrial building project in Tokyo and Singapore. And when I was in Singapore, I was a BIM manager as well. And I was in charge of the high-rise building and the airport facility for the BIM management. And after that, I shifted to the computational design field to standardize the corporate insight and resolve the complex design issue, including the sustainability design and the utilization of the neural network. And those are quite related to my research program in my PhD course. And I was focusing on the BIM utilization, especially in Japan. And I completed the PhD last March. And starting from this October, I started my new career together with Takenaka in University of Tokyo. And also my focus is staying on the building information modeling. And what I'm looking at is to take this data from the building project out to the broader context, like the urban design or smart cities or some more industries that will be related. So first, let me introduce about the corporate and also the BIM and computational design from our latest experience. Takenaka has been in market more than 100 years in Japan. And actually our corporate history starting from 1610, more than 400 years ago, as a group of carpenter. And we transformed into the modern corporate at 1899. And at the moment, we have 24 international branches, including the Singapore branch. And the Singapore branch was established on 1974. So we are in the deep relationship with Singapore for more than 50 years. And the project includes the commercial development, often HDB development, and some for the cultural facilities like National Art Gallery or LaSalle College of the Arts. And what I was involved was the Capita Green, the Market Street Tower, and also the Changi Airport Terminal 4 project. So these are the ones I was involved as a BIM manager. So at this time, the BIM was still at the stage of the progress. So not everybody was clearly understanding that what was the benefit and what was the point to leverage this technology and the very rushing project But gradually, I became aware of what is the benefit that we should enjoy. And also that was gradually shared among the BIM team in and out the project team. But honestly speaking, at the time, among our hundreds of project members, the BIM team was only 14 people, and also the BIM related architects are at around 20-30%. And so despite we say that this project was quite successful in terms of the BIM implementation and utilization, still BIM was for some people in the project team, and for the majority, they are full steam ahead for their daily issues, and they are sometimes keeping away from the use of BIM. So that was the beginning point of my PhD research, that what is the ideal and good relationship between the project progress and the BIM utilization. Having said that, after the completion of those projects, it's been already 5 and 6 years. So Takenaka accumulated some knowledge and know-hows for the BIM projects. So now we can do more in a single project, and also we are distributing the insights and knowledge throughout the company branches. So this is one of our latest BIM project called 3A headquarters, located in Osaka and completed in 2020. And the project was fully coordinated by BIM. And this was the head office for the steel fabricator. So they also wanted to treat this project as the technology showcase. So that is why the building wall and the steel structure is tilted to demonstrate that how precisely they can fabricate. So that was a starting point, and we designed this 3-story office building, but having the careful coordination for the building volume and acoustic and sustainability performance, and much more than that for the fabrication feasibility. So because the owner was the steel fabricator themselves, so we could have the deep communication over the project fabrication BIM model for the fabrication method and installation method. So that is why we could develop this structure model straightforwardly from the design side to the construction side. That is partially because we are design build contractor, that we perform the design and construction at the same entity. But not only because of that, the deep commitment from the client side was the most remarkable point in this project. And it was concluded in a very precise finishing using by the steel structure, and also the timely delivery of this project as well. This is another example called Chuo University, completed in 2021, and this is the new faculty building for the university. And as you can see, at the center of the building, we have a large atrium, and the problem here is to achieve this large space, large air volume, without compromising the sustainability performance of the building, because the university needs to achieve the higher level of environmental performance all the time. So what we did is to take this design intention as granted, and we try to minimize the sustainability impact by making this large air volume. So we conducted the rounds of the sustainability simulation, but at the same time, we try to visualize this simulation result to the client side as much as possible, so that we could sit on the same page all the time to share the understanding for what we actually need to achieve and what to be prioritized throughout the project. And to do that, we were using the virtual reality with using the head mount display, and not only using the out-of-the-box commercial product, we did some customization to visualize the environmental factors, which is basically invisible in the completed building, but can be seen in the VR environment. For example, these arrows that you can see in this perspective view is showing the estimated airflow with the estimated air temperature. So by doing that, we can compare the different roof design, which can be seen here, to evaluate that what is impactful and what can mitigate the negative environmental impact to the building atrium. So likewise, we did the same thing for the acoustical performance and thermal performance, and to develop the design step by step by seeing the actual effect in the visual. Talking about the construction site, there's a movement in Japan that 5 major general contractors are making an alliance for the robotic platform to be used in the construction site. So the bottom side, you can see several robotic technologies, and those are mainly for the construction use, like the cleaning robot and the welding and some construction work robot and the assisting robot. Those are fabricated by the different vendors, and they expect the different information to work precisely. But for the construction site, what we basically have is the precise building information model. So what we essentially have to do is to bridge the difference between what we have and what the robots expect. So what Takenaga aimed is to develop this robotic platform across the industry. So we made an alliance on 2020 with Kajima Corporation and Shimizu Corporation, and we decided to develop this robotics platform together with a collaboration to the corporate like AWS or Mitsubishi Electronics or NEC. Those are the IT side. So this is a new movement that the top five general contractors were working independently, but recently we were selecting the collaboration field to tackle with the industry-wide program. In my understanding, the necessity for that kind of collaborationship is coming from this necessity for the building information modeling for the digital transformation. So this is a material from the Dodge International, and the report can be downloaded from this URL. But some research in this report says that the digital transformation is strongly pushed up if you've already using BIM. So this chart says that, for example, here, VR, AR, MR, those immersive experience is used in BIM users and this much, whereas in non-BIM users are this much. So as you can see on the left side and right side, the BIM users are more advanced in terms of the digital transformation technology use compared to the non-BIM users. So it can be said that BIM is becoming the infrastructure for those digital transformation in AEC industry. So that is the next stage for the BIM, that BIM is not only for our production use, but much more for the connectivity for the surrounding technologies. But as I've mentioned earlier, the question is that, is BIM for everybody actually? So as I can see around, and perhaps you can see around, that some are deeply committed to BIM, but some are not. So I was actually at the beginning, I was quite frustrated at why those people are not coming in and joining into the new technology. But it's always case by case, and we need to see the the background that why this kind of thing happened. Actually, the data shows that the BIM adoption rate across the industry in Japan is shown in this chart, and the blue is BIM ready and red is not. And this vertical layer shows the scale of the industry, and the top one is a smaller industry, like the company have 1 to 3 employees, and the bottom one is with the one for more than 5,000. So as you can see that the larger firms and organizations are really moving forward to the BIM, but the smaller ones are still hesitating to coming into BIM. So this is a gradation, and depending on the context, somebody needs to drive the whole industry to come to this new digital steps. And I believe that in Singapore, government is playing a very important role, and I hope Japan to do so as well. But actual driving force in Japan is actually performed by the larger player like this. So in terms of that, the large construction companies are really responsible for this industry's digital transformation. So how can we actually influence the others in a good manner to come into BIM, and how can we look at ourselves in terms of the adoption of BIM? Because basically, this BIM adoption rate is measured by the existence of BIM players. So if in the very contrasted situation, the company has 5,000 employees, but only one BIM player exists. But in those cases, also the company say that we are BIM ready. So what we need to look at is what's happening at the player level. But doing so is not easy. So I was finding a way to do that by using the data. And what I did actually in the PhD program is to discover the types of the behavior of actual BIM players from the software record called BIM log. So I did the process mining onto the BIM log, the BIM record, to categorize the types of BIM contribution of each BIM players. And what I discover is something like this. And how you can look at this diagram is that we have the department for architecture, engineering for structure and MEP, and the technical department for the construction. And basically, as a general contractor, we have all of them under the same umbrella. But there are some horizontal layers that there are project managers, and there are persons in charge, and they are more frontline BIM technicians, but sometimes they are external people who are short-term hired outsourced personnel. So those are basically the outside people. So they can be trained and they can be fully committed to the project. But once a project is over, then it's natural that they move out and they look for other projects. So for the corporate, how they can accumulate the knowledge for internal, not for the external, but internal people, that is the key. So which is illustrated in a yellow. So looking in depth, what we discover is the level of commitment, and which is labeled by this G1 to G4 and sometimes non-BIM. And this is a schematic diagram, but this is what frequently happens in the actual project. So G4, G3 can navigate BIM, but actually they don't make significant input to the project BIM progress. And actually those BIM modeling is performed by G1 people, but often G1 people are outside the outsourced personnel. So what we need to rely, who we need to rely on is this G2 people. So D2 are not as proficient as G1 in terms of the modeling skill, but since they are inside the company, so they can talk to other professionals and other departments quite easily. So they work as a hub or bridge to the or for the project communication. And actually those G2 staffs are the key for the project for the successful BIM. So this is what we discover supported by the building BIM log. And what we can conceptualize this is inspired by this, the keystone species. Keystone species is the concept from the biology, and this keystone species are the specific species found in specific ecosystem that has a larger impact than the actual number of the existence. So they are few, but have a very big impact once they are removed from the ecosystem. So for example, those otters are one of the keystones. So once you remove the otter from one specific ecosystem, not only the otter disappear, but the whole ecosystem will be destroyed and it never comes back. So that kind of thing is happening because of the existence of keystone species. So treating these G2 people as so proficient BIM people is just one way, but treating as a keystone species will be much more effective for the BIM implementation for the organizations. This is what we found, what I found throughout the doctoral program. So knowing about those, how it's moving, then what we need to look at is about the future. What I'm researching at the moment is the relationship of BIM and gaming engine and NFT or Web3. Those are quite deeply associated together in terms of the mirror world. The building information modeling is basically about a single building entity, but it's ultimately necessary for the broader context like urban simulation or smart cities. But as you know that BIM is not really for the visualization. So having tens of the building inside the BIM environment is quite a big issue. So we need to look for some other technology like gaming engine, where the visualization is very fast and the real-time simulation and real-time visualization is maybe possible only here. And there are some additional insights about the artificial intelligence, much more than the AEC industry. So the collaboration with this industry will have a lot of insight exchange. And NFT and Web3 is much more for P2P interaction. So this is the give and take of the data, what we have and what they have, and how we combine them together, and how we set the security and privacy each other. But looking at the BIM side, there are some issues like the model attribute that we never have the full set of the BIM model attribute all the time. And sometimes the model attribute requirement is overwhelming and very hard to achieve. So what we need to think is originally if it's necessary for the future use. So this is quite well-known cartoon that what we design as an engineer is something like this, but actually what customer wanted is just like this, as simple as this. So we tend to deliver this kind of model because we produce this model for our needs, and this could be the use of the client side as well. And of course, the client may expect us to create the high quality model, but thinking about the operation and the interchange of the model value, the model could be much more simple like this, the Lego block. And often the understanding for the building by the layperson is like this, that there's a wall, there's a window, there's a door, and there's a floor. But basically they have no idea for what's inside, and it's often meaningless. So then how can we merge those two different requirements together, and how we can streamline the production? This is a question. But as you know that the model development happens along the project timeline, and basically rolling back the LOD doesn't make sense because the model is already complex, and taking this back to the simple model or the box model is almost meaning to remodel everything. But there should be the way, and what we need to sacrifice is the 100% precision for the model, but there should be a tolerance for the acceptance, and we should find a way to agree that to what extent the model should be precise and model should be detailed. And if it falls on somewhere around here between LOD 200 and 300, then this is where we actually should target rather than develop the model more and more. And it's necessary, but it's for the production, not for the broader context, so that we can have two different goal set and we can streamline the production line. I think that's the way to go ahead. So thank you very much for attention.
Thank you, Prof. ISHIZAWA. It's a very in-depth sharing. So actually, there's a lot of content being shared, and at the project level, together with some of the problems. So I remember earlier on during your time in Singapore, there's actually a sharing on the capital green. So I remember very clearly that you explained for the production together with the design, with one concept, it tackles everything, which is the least joint. So I still remember until now. So so with I think it's very, very inspiring. So for now, what you have shared with us is actually the people, right? So in your PhD that you mentioned, which is the key personnel that do the most impact. So from here, yes. So from our side, we are also encountering a lot of issue. So to go beyond BIM, because we understand BIM has been here since many years ago, and we in Singapore, we started to mandate BIM submission in the year 2012. Then 2015, all regulatory submission was mandated. Then we move on forward. 2015, we explore VDC. Then in 2017, which is 5 years ago, we introduced the concept of IDD, integrated digital delivery, that you actually incorporate in your projects. There are VR, AI, data-driven approach. These are, to us, is actually some of the IDD components. So beyond BIM, and there are other technologies that supplement the entire collaboration, integration. But the thing is, like what you explained, why people are still reluctant. They refrain. They do not want to engage this. So maybe in a smaller firm, because of contractual needs, they do not need so, right? So but in a bigger firms, they do have the capacity. So therefore, they can actually go extra mile moving forward. So from these few years, we also explore a ground up approach, where now we are having some sharing sessions every month. So lunch talk, we invite people. So from the industry, from IHL, and from international experts like you to share. So this is our efforts now. So for now, right? One key question is how you mentioned there are business-driven approach by the key larger firms moving forward. So as compared to Singapore is top-down. So we have government that supports it with grants. So therefore it might be easier. But for the people, for the training, So what do you advise? Because when we are looking at this contractual, they do not need it, but in actual life, things are moving on so fast. If we do not catch up, we will be dropped behind. So especially in Singapore, there's no resources. We rely a lot on people. So people is the key resources. So the method, the strategies is the key that we want to promote. So how do you look at this point perspective of view to drive this technology adoption?
Okay, thank you very much for the clarification. So also, I clearly remember what happened in Singapore, and at that time, and even today, the Japan really wants to learn from Singapore that how the BIM transition went that fast and how it could be so impactful for the entire industry because not only because Japan is relatively large and Japan is relatively private driven, but it was the power of vision in Singapore that what we, I mean, that from the Singaporean perspective view, that what we need to achieve and why this current situation is not acceptable. So in terms of that, Japanese construction industry is quite saturated and they are not really moving by everybody's power, but it's much more like the localized optimization depending on the project types. But having said that, the common language between the Japan and Singapore I found is about the working system that we need to look for the BIM external BIM specialists to tackle with the large, especially the large scale project, because the project moves very fast and also the authority commitment to the authority requires the deep communication and which has to be done by the licensed people. So what we can basically outsource is the modeling job and the coordination job. And those things can be shared, but some licensed architect work cannot be shared because it's licensed. So that is the basic one and that we need to accept. And afterwards, then the thing is that what we actually need to have inside and what can be outside. Then the actually what I felt over this PhD program was the BIM training or education program is too simplified that the training always say that everybody needs to become a modeler. So they need to create a BIM model from scratch and we have the blank file and you need to build up this building. That's one way. But for the project coordination, much more than what they need to do is to supervise the model to ensure that it's going well or not. And actually it has very little to do with the modeling skill, but it's much more to look at the model to find the error or find some miscommunication and to actually rectify and reflect it to the model. So then viewer is really good enough. But the thing is, the people shouldn't be afraid of getting into the model because it doesn't collapse. So just they need to open up the model and look around, and it doesn't take long. So it's just 10 minutes per day. So it could be done. But telling them to become a modeler is quite out of the point. So that's the point. And to visualize the thing, I have one diagram that may be share worthy. That this is the one. So you may know about the Rogers distribution of innovation that a few people are always innovators and they are really coming into the new technologies swiftly. And after that, a good amount of people becomes an early adopter and they look at the technology very positively. But there's a very big gap between the majority. And once we go over this valley, then we can talk to the large amount of people. But still, some people are called laggard, and they basically refuse to migrate into the new paradigm. So that always happen no matter what it is. So then taking this as a base, so what I've introduced here, that G1 to G4, and G1 is the proficient modelers and G4 is rather the observer. But what I could identify is only this portion, and the rest is non-BIM, and I couldn't address because they produce no BIM data and no BIM log. So I couldn't talk much about these people, but what we can foresee is the expansion of this portion, and this non-BIM people gradually migrate into this G4 and hopefully G2, G3, and G2. But for the G1 modeler, is still for the specialists, and the licensed people and the project core people still need to stay at the stage of G2 or G3. The BIM savvy or technology savvy, but the actual tasks are outsourced. Those are the attitudes for G2. And G3 is a supporter. So they don't operate by themselves, but they support the BIM project. And G4 is, I don't know about the attitude, but basically they have a skill to open the model. So this portion will expand, but not till 100% because of this innovation theory. There's still some people will stay at the laggard side, but this is for every aspect. For example, I'll be somewhere around here for the BIM thing, but for the construction coordination, maybe I will be somewhere around here. So it's depending on the expertise and depending on the expected role. So we can't blame that some people are not really coming into the majority because of the work sharing and the project configuration, but at least we expect them to come into this G4 that you open the model, see what's going on, and that's already a BIM professional. That kind of positive affirmation is really necessary, but it's something at the moment lacking, and then training or learning perspective, I think.
Thank you for the sharing. So understand that you are trying to actually push those non-BIM adopters actually to engage BIM by looking at different tiers of engagements, right? So by just opening the file, then you can actually understand more for the collaboration needs. So I believe BIM is about communication. So this is the one statement, another statement that you mentioned earlier that I recall. So it's about talking and keep on talking. So for now, right, let's open the question to the floor. Anyone from the floor that would like to raise some your inquiries? So there's if no, I have I actually I have a lot of questions.
Okay.
Yeah, because for now, actually for our side, right, for digitalization side, moving on forward, like what you explained just now, there's actually a graph. Beside the people, there's also data. So in Singapore, we are moving on forward with the CoreNet X. CoreNet X is actually meant for regulatory open BIM concept. So it's a subset of IFC. We call it IFCSG. So IFCSG is actually is meant for compliances needs. So there are 7 key agencies in Singapore that looks after the submission regulatory requirement. So for here, right, we understand IFCSG is meant for open BIM interoperability, where all the data is actually captured, could be captured in a parameters. So that when the agency take the model, there are available parameters for them to check. So this is actually the IFCSG that are reflected in your slide. I saw one component is IFC. So there are also other parameters as well. So for my question, right? So there's actually one concept that we explored, so which is data drop. So like what you mentioned just now, you do not need to, actually there's two questions. One is to have the entire regulatory data being captured in the model is very heavy. So for submission, yes, but for project delivery, for costing, contractor might not need that. So for fabrication, they might not need that. So just now your explanation is maybe there could be a two-tier branching. So one is for fabrication, one is for the general users. So with the compliances. So this is the discussion we have for the data drop. So, but the thing is, if we do not capture certain downstream requirement, for instance, FM. So FM would be maintenance. So for Singapore, we have released recently in the year 2021, we also released some guide with the CDE and also design for maintainability. So maintainability refers to the accessibility of that particular building. So there are a lot of considerations. So if we do not capture that upfront, right? So there will be concerns. This is actually another concept we are toying with. So just recent we call it IBEW now, because your time we call it SCPW. In Singapore, we have an annual big event. So to host everyone together to share the concept. So integrated planning and design is the next phase after the IDB. So we are hoping to have a downstream requirements captured upfront so that the entire thing can be streamlined. So why? Because normally people will just do I can share just enough, but the sharing of just enough doesn't mean that I consider less. Yeah, so I can consider more, but just that for this particular phase, I just share enough information because you do not need everything. So I mean, what's your thought and experience in this with the project that you shared? So we are hoping to learn more from your side. Yes.
Okay, thank you very much. I might say that my approach is for the minimum definition, or I might say the minimalism BIM that that can be enjoyed by many people, but it's much more for the general description for the building and the functionality, and it's not professional at all, but based on the professional input, and this is streamlined and simplified for especially for the targeted downstream use. So it's not the final deliverable of the project, but it's intended use for the building life cycle after the building completion. So that was considered something that's automatically achievable once we complete the full set of BIM model. And in a sense, that's true, but that, as you mentioned, that's a full set, but that doesn't automatically ensure that it's enough for some other use. So the thing is that how can we satisfy ourselves by the agreed parties, and how we can find out the way to deliver by the minimum effort. And that concept is basically enabled by the contractual background that is, especially in Japan, the contractual regulatory is very minimum, that you know that the standard Japanese construction contract only has 33 pages, and it only said that you should work to meet with a trust, and once something happened, that you should sit down together and resolve the issues together. That's basically what they say. So that's quite different from the Western contractual concept. So if we need to perform on the Western contractual context, then that kind of minimum work set will not work sufficiently, because there should be a skepticism that by doing so, the contract will neglect the work and contract will keep away from what they actually need to do, or they don't meet to the client needs. So, and that could happen, and that's why contract is necessary. But the contractual concept is hugely different place by place and project to project. So I'm looking at that because of this Japanese mutual understanding based contractual culture, but it's partially acceptable in Singapore. But I know that basically the contractual style in Singapore is British based, and it's somewhat different from what we are usually used to. But there should be some way to interpret that this is a core value for everybody, and this is additional value for some limited party. So you say that it's two-tier, and I believe it's so, but it's not horizontally separated like this, but it's much more for the commitment to the project. So if they are in the core, they should be able to enjoy more value, and if they are at the peripheral, they can enjoy, but it's some, so it's less prioritized. Then how we can do that, and what is the general principle for that? It could be discussed. That's the concept.
I see. Thank you, Prof, for your sharing. So using the contract to manage the item, yeah, it is actually a strategic approach, and understand that in Japan, so you have this strong contract for everyone to work collaboratively together to resolve the issue, which is slightly different as compared to the Western side for just enough approach. Okay, so is there any more questions in it from the floor? So let me check the chat. Yeah, if there's no, actually we have reached to the end of the 45 minutes sharing, and it's a really a very insightful sharing, although it's short, but there's a lot of item being shared in this session, and I really appreciate your sharing, and we look forward to the next session, maybe next year. So for it, yeah. So thank you very much, Prof. ISHIZAWA for this generous sharing.
Thank you very much for this
Thank
time
you.
around. And next time, I really hope to come down to Singapore once again and have the Hokkien Mee at the Lau Pa Sat food market. So,
Yes. It's still there. It's still there. Yeah.
okay.
Okay.
So looking forward to the next time. Thank you very much for the invitation.
Thank you very much. Thank you, Prof. Yeah. Have a nice day, and bye-bye.
You too. Thank you very much.